Have you or someone that you care about recently been diagnosed with type 2 diabetes and you're wondering what it is? Have you been told that type 2 diabetes is related to insulin resistance, but you're not sure what that means? In this video, I answer those questions. Hey everyone, my name is Jeremiah Farias. I'm a registered dietitian and I've been researching health and wellness for over a decade now. I help adults suffering from blood sugar dysregulation issues, things like type 2 diabetes, prediabetes, and low energy levels. I hope you enjoyed today's video. If you've recently been diagnosed with type 2 diabetes, you're not alone. The prevalence of type 2 diabetes is only continuing to grow. As of 2022 CDC data, around 37.3 million adults have diabetes. 95% of those are type 2 diabetic cases. So that's around 35 million adults in the United States with type 2 diabetes. Rates of prediabetes are even higher. It's estimated around 96 million adults, which is 29% of the United States population, have prediabetes. So this clearly is an issue. Unfortunately, the United States not only has an issue with type 2 diabetes and prediabetes, they also have a metabolic health issue. One paper published in 2022 from the Journal of American College of Cardiology found that only about 6.8% of US adults are metabolically healthy or have optimal cardiometabolic health. This means their body fat percentage, their blood pressure, their blood sugar, their lipids are within ideal ranges, and they have no history of cardiovascular disease. So this is quite striking that only about 6.8% of adults are considered metabolically healthy from a cardiometabolic standpoint. So what is type 2 diabetes? I think the best place to start is asking, how is type 2 diabetes diagnosed? And type 2 diabetes is diagnosed using primarily 3 blood markers. The first one is fasting blood sugar. Second one is fasting A1C. The third one is called an oral glucose tolerance test. So I'll go through each of these individually. So the first, being the fasting blood sugar, is you are fasted, usually overnight. Someone's getting their blood drawn that morning without eating anything, just drinking some water. And if their blood sugar is above 126 milligrams per deciliter, this is usually on 2 separate occasions, the person will then be diagnosed with type 2 diabetes. For A1C, this is a marker assessing something called glycated hemoglobin. So when one consumes carbohydrates, those carbohydrates can bind to proteins called hemoglobin in the blood, and that process is called glycation. Anytime a carbohydrate binds to the protein, glycation is the term that's used. So it's assessing this glycation process. The higher the number, the more glycation. So if someone has a A1C above 6.5%, then again, usually on 2 separate occasions, they're diagnosed with type 2 diabetes. And the last one, not used very often, but still a tool that's utilized, is an oral glucose tolerance test, where someone is consuming a dose of around 75 grams of carbohydrates in a drink or liquid solution. Their blood sugar is then checked 2 hours after consuming that solution. If their blood sugar is above 200 milligrams per deciliter after 2 hours, they're diagnosed with type 2 diabetes. So really, the diagnosis of type 2 diabetes is based on certain blood glucose markers or values. And if you're wanting to know what causes type 2 diabetes and insulin resistance, be sure to check out this video. So we just reviewed how type 2 diabetes is diagnosed, but what is type 2 diabetes? Some terms you may hear are glucose intolerance, insulin resistance, and we will cover insulin resistance, what that specifically is, a little bit later. But those are some terms that are thrown out there to describe type 2 diabetes. Someone cannot handle carbohydrates, even a carbohydrate intolerance. And while those are true to a degree, I argue that truly type 2 diabetes is a situation where there's impaired cellular energy production, impaired metabolism occurring. The glucose that is going into the cell cannot be oxidized or used to produce energy. And as a result of that impaired ability to oxidize glucose, there's a litany of other ill effects that are occurring, one of which is, I argue, insulin resistance. There are many papers that highlight that in type 2 diabetes, there is decreased glucose oxidation and utilization in the cell. And there's also other studies highlighting that in those with type 2 diabetes, the mitochondria's ability, which mitochondria are those energy producing powerhouses of the cell, energy producing organelles, they produce cellular energy called ATP. Mitochondria in those with type 2 diabetes are not producing ATP to the same degree from the fuel that they're receiving. So clearly, it's a metabolic issue. It's a metabolism issue, a cellular energy issue. Hey everyone, I wanted to take a quick break from the content and share with you a free guide that I created. It's titled 5 Steps to Improving Your Blood Sugar Metabolism. In it, you're going to find a lot of practical information that you can begin implementing today to start changing the way that your body uses glucose in the cell. And if you've checked out any of my previous videos, this is what I believe is the primary culprit that's driving blood sugar metabolism issues like type 2 diabetes and prediabetes. You're going to get specific information going over the importance of protein, the types of protein to consume, and how to even calculate how much protein should you be having on a regular basis. The quality of carbohydrates you should be including in your diet. Again, previous videos I've gone over highlight carbohydrates aren't the problem. It's your body's ability to utilize them. However, quality of carbohydrates, quality of food do matter. And so in this guide, you'll find information on the carbohydrates, certain fats that we want to avoid or limit, and the others that we want to include and prioritize, along with a lot more information. You'll be able to find the link to download this guide in the description below. Another term that's often used with type 2 diabetes is insulin resistance. Insulin resistance is a state where certain cells of the body are no longer responding to the signal of insulin. Insulin resistance contributes to type 2 diabetes. Insulin is a hormone that supports glucose uptake into the cell. It also signals the liver when there's carbohydrate or glucose in the bloodstream, so the liver does not continue to release or produce glucose. In the state of insulin resistance, insulin levels continue to rise. The cells are not responding to insulin, so the body releases more to try to correct it and override that lack of response. And insulin is not only being released at higher concentrations to help regulate blood sugar levels, it's also increasing a process called mitochondrial oxidative phosphorylation, which is basically meaning the production of ATP within the mitochondria, which is what produces that cellular energy ATP in all of our cells. So interestingly enough, insulin does increase that. And so as insulin resistance progresses, you then experience something called hyperinsulinemia. So despite this hyperinsulinemic state or high insulin levels in the blood, when you have cells of the liver and pancreatic beta cells that are insulin resistant, this is causing all of the issues seen in type 2 diabetes. So when someone consumes a meal containing carbohydrates, normal physiology is insulin is released from the beta cells, and the insulin is not only signaling the liver that we have enough food, there's glucose present in the bloodstream, all is well. It also signals the alpha cells of the pancreas. So in the pancreas, you have alpha cells and beta cells. Beta cells release insulin, and the alpha cells release a hormone called glucagon. So when you are in an insulin resistant state, when someone consumes carbohydrates, insulin is released in response to those carbohydrates. Insulin attempts to let the alpha cells know, hey, there's carbohydrates, all is well. That signal not received. So instead, the alpha cells assume we don't have enough carbohydrates in the bloodstream. Insulin is not present. So we are going to release glucagon. Glucagon is released into the bloodstream, sent to the liver, and it supports many processes, but primarily two as it relates to diabetes and increasing blood sugar levels. One is glycogenolysis, which is breaking down glycogen, which is stored carbohydrates in the liver, to release to the bloodstream to raise glucose levels. It also increases a process called gluconeogenesis, which is breaking down proteins and fats, converting that in the liver to glucose. And so this is what is causing the high blood sugar levels that are seen in type 2 diabetes. It's because the pancreatic beta cells are insulin resistant and the cells of the liver are insulin resistant. You may be wondering, why are particular cells of the body becoming insulin resistant? The purpose of this video is not to delve into specific mechanisms or factors that drive this insulin resistance. I'll refer you again to a previous video that I created, but I also want to let you know that future videos will address other factors and go into more depth on some of these factors that do, in fact, drive insulin resistance. One of the last things I wanted to discuss is the idea that insulin resistance may be intentional by the body. This sounds maybe a bit crazy. In conventional medicine, we're often taught, or the mindset is, the body is broken, therefore we need to fix it. It doesn't know what it's doing. I'd argue that's not the case. The body is quite wise, and it often does things for a particular reason. I always want to know, why is the body doing these various things? Why are, for example, cholesterol levels increasing? Why are blood sugar levels rising? Why are cells of the body becoming insulin resistant? And believe it or not, there are papers that ask these same questions. The study that I wanted to look at is titled Insulin Resistance is a Cellular Antioxidant Defense Mechanism. And it highlights that when mitochondria receive more substrate or nutrients than they can handle, there's an increase in something called mitochondrial superoxide. And there's a strong link between increases in mitochondrial superoxide production and insulin resistance. So it highlights that insulin resistance may be an appropriate response whenever there's too much substrate, things like glucose, things like fatty acids, coming into the cell, coming into the mitochondria, than it can handle. If the body, if the cells just continue to allow more and more of these nutrients, of this fuel, it would eventually damage the cell and eventually kill the cell. So if the cell is insulin resistant and it puts a brake on how much substrate can come in, it can reduce the oxidative stress and the damage that it experiences. So again, it's intentional. We can see these things as mistakes. As I mentioned before, the body is broken, but in actuality, it's responding accordingly to the nutrition and lifestyle habits that we have, along with potentially harmful environmental exposures we may be unaware of. It's responding accordingly and intentionally. You should now have a better idea of what type 2 diabetes is and the role that insulin resistance plays in the development of type 2 diabetes. It should also be said that type 2 diabetes and insulin resistance are not a result of eating too many carbohydrates. There's a lot more to it. And again, you can check out a previous video that I made that discusses what actually drives type 2 diabetes and insulin resistance. I hope you enjoyed today's video. If you have any questions about the content that I reviewed in today's video, let me know down in the comments. You can also request topics that you'd like me to cover in the future. If you're interested in working one-on-one with me, the best place to start is scheduling a free 30-minute discovery call that I offer. I am credentialed with a couple of insurance companies, so there will be a link in the description that allows you to check if I accept your insurance. Don't forget to download my free guide, 5 Steps to Improving Your Blood Sugar Metabolism. That link will also be in the description. If you enjoyed this video, please don't forget to give it a thumbs up, share it with someone that you think would benefit and enjoy it, and also don't forget to subscribe. I'll be releasing new videos every week, and I don't want you to miss those. Thanks again for taking the time to watch this video. Take care. Have a wonderful day.